Hello, and welcome to the Trenchless Technology webinar series. My name is Mike Kesdy, Associate Editor of Trenchless Technology magazine, and it is my pleasure to introduce our presentation, Manhole Rehabilitation, Understanding Why Hybrid Epoxies are Replacing Calcium Aluminate. This webinar is sponsored by Cladliner. Hybrid epoxies are quickly becoming the prominent solution for manhole rehabilitation and protection because they combine the ease of application and economics of a cementitious liner with the performance of a high-build epoxy liner. This webinar is designed to explore the properties that make a liner suitable in wastewater environments, understand the characteristics of hybrid epoxies, compare hybrid epoxies to calcium aluminate, pure infused calcium aluminate, and traditional epoxies, recognize beneficial application methods of hybrid epoxies. Before we begin, we're going to take a quick poll, so please submit your answer and then click the blue Return to Presentation button. Presenting today is Dmitry Rapanyos, a certified NACE coating inspector, specializing in coating systems for water and sewer infrastructure. Dmitry's expertise lies in his collaborative work with engineers and certifying contractors to ensure high standards in protective wastewater system rehab and lining. He has been at the forefront of product development for hybrid epoxies in the industry and is a chief product developer for Cladliner. He has set out to improve and perfect the traditional, often unreliable technologies used to rehabilitate and restore manholes. Following the presentation, there will be a question and answer session. We encourage you to participate by typing your question into the designated panel in the left-hand portion of your screen. You can also maximize your viewing window by clicking the box with the X at the upper right of the slides. Now please welcome our speaker, Dmitry.
Good afternoon, folks. Thank you, Mike, for the introduction. Vicky, thank you very much. The folks at Trenchless Technology, thank you a lot for all of this. It's always wonderful being part of this educational process, and look forward to hopefully sharing some valuable information with everybody today. Looking at our audience very briefly through the sign-ins, we have a nice combination of city, municipal folks, contractors, and a couple engineers in between. So I'm hoping that this presentation is rounded enough while not being too detailed so that hopefully it can get some value out of it for everybody that's here today. We typically have a really good Q&A session at the end. So hopefully any questions you have will be answered throughout the process, and hopefully if we don't catch you through the process, we'll do that at the end. So today I'd like to talk to you a little bit about understanding hybrid epoxies and what it is these new hybrid epoxies are and how they're being used. So let's give a little background really quickly. First and foremost, I'm going to give you a little bit of background about the industry in general regarding concrete, manholes, and infrastructure as a whole. We're going to talk a little bit about traditional manhole rehabilitation solutions that have often been part of this industry, cementitious coatings, epoxies, etc. We're going to talk a little bit about this new technology that we're addressing today. We're going to spend most of the time over here in this section, and we're going to talk about the uses of this new technology for the mitigation of corrosion in this wastewater environment. And then we're going to briefly go over a couple of case studies of two situations where this product or this new technology was used to effect in the field. And then at that point, if you still haven't fallen asleep or if you're still interested, we'll have a good Q&A session to follow up to make sure that everybody leaves complete with the process. So let's start off, before we start with our first slide, I want to ask you a question first. This will be our first poll. Question is this. According to the ASCE, which is the American Society for Civil Engineering of 2017, according to the infrastructure report, what grade would you think America's infrastructure would score? I know infrastructure has been on everybody's minds for a long time, but it's been brought up very regularly recently. What would you think your score would be? Would they be rated an A on a scale of A through Z, of course? Would it be a B, a C, a D, or would it be an F, which of course is a fail, as we know it's school grading purposes? So take a minute and take a look at that, and let me know what you think the grading is. Okay, so taking a look at some of the poll results, it looks like most of you were pretty accurate. What we're finding is that according to the report, the infrastructure report card is at a D+. Okay, so that doesn't bode very well for it, does it? Now, let's be a little more specific regarding water and wastewater infrastructure as we know it and as we're working on it today. America's infrastructure typically, as we said, on a whole, gets a D+. Okay, more specifically, however, water and wastewater as a category also received a D+. So it's right there kind of where the worst of it. I wish with all the money that's been spent over the last few decades that this was higher, but we're still lingering down there at the D+ level. The estimate to simply maintain it at this current standard over the next few decades is $271 billion, okay, and to meet the future demands. This does not mean upgrading it to a level of a B or an A even. So we can see from that what we're cut out for. So let's look at manhole restoration specifically. This is particularly what we're dealing with here today. When it comes to manholes, this is obviously a part of the entire collection system of water and wastewater. Okay? Some of the considerations we need to look at when we're considering options for manhole restoration. Number one, you want to look at the current condition of the manhole. So what state is the manhole in? Do we have a lot of leaks? Do we have a lot of structural defects? Do we have major hydrogen sulfide degradation? All these factors determine which kind of system or restoration process makes the most sense. We also have to look at the corrosion elements. So do we have really dry conditions, as in the desert areas? Some of our clients out in the Arizona area have a lot of hydrogen sulfide, but very little I&I or water issues to deal with. Some of our areas up in the more mountainous regions, up in the Pacific Northwest, for example, those of you out there, I saw Clean Water Services out here on the webinar today. They are very accustomed to getting a lot of I&I, but because of the mountainous regions they have, there are a lot of lines that are not so corrosive when it comes to H2S. Then we've got to look at our budget. Obviously, in a perfect world, we would use the most high-quality product for all our infrastructure to make sure that we protect it on the long term. However, that's not always feasible. So we need to look at the budget we have based on the number of or the amount of infrastructure we need to rehabilitate in order to make a good economic decision as to what system to use. And then, of course, we also have to look at the effectiveness of the solution. So we've got to find a solution that's effective in that it works for the environment that it's placed in, works for the budget we have, and for the elements that it's been affected by. So let's look at corrosion a little bit on its own. Okay, so when we look at corrosion, and this specifically as it pertains to concrete structures that we find in wastewater environments, that manhole picture on the right there gives you a good idea of what I'm talking about. Microscopic organisms that come from wastewater, we know this as H2S, or hydrogen sulfide gases, okay, embeds itself in the porosity of the concrete structures. Concrete is an amazing material. It's strong, it's economical, but it is somewhat porous. It's a bit of a sponge. So what ultimately happens is this bacteria colonizes in this structure or the matrix of the concrete, and the byproduct of this colonization of bacteria is hydrogen sulfide. I apologize. Hydrogen sulfide causes the bacteria. The byproduct is sulfuric acid. So sulfuric acid is what causes the degradation of the concrete in manholes. Those of you who are very familiar with concrete will know that a concrete that has a very high pH, okay, pH is measured on a scale from 1 to 14 typically, 1 being the most acid, 14 being the most alkali, and 7 is the neutral number. Concrete is strongest when it has a high pH, neutral or better, and it will continue to strengthen for many years. We'll get into a little more detail on that as we progress. However, once this pH drops below the 7, the strengthening process actually stops, and once it drops below neutral, the concrete actually will begin to weaken. Concrete with a high pH tends to strengthen for years to come, and in fact, even decades, and some people think possibly even centuries. So let's look at our restoration and protective options that we've typically come across. So what have we used over the past to protect this porous concrete from degradation? Okay, traditional restoration and protective lining typically falls into two major categories. We've had the high-performance polymers like epoxies and urethanes and high-bold spray-ons or hand-applieds, and we've had cementitious liners. The cementitious liners, of course, are the traditional Portland-based cement ones, which are similar to what the structure is originally composed of. And we also have more higher performance cementitious products like calcium aluminate and pure fused calcium aluminate. So let's look at epoxy as an option for rehabilitation. A couple of advantages and disadvantages of typical epoxies, okay? The advantages are typically we get good chemical resistance and we have the potential for high build. Now, epoxies are not magic products, but what they do is they can handle acidity well. In fact, they handle acidity much, much better than concrete does. So the barrier that they form between the acidity and the concrete is what protects the concrete long term. Some of the disadvantages of epoxies, they can be expensive, and of course there are some complexities that come with it with regards to even more so with urethanes and high build polyureas, but with regards to the sophistication of the equipment for preparation, for application, the conditions and environment in which they have to be applied, moisture, humidity, all those things play a factor that could affect the quality of the application of the epoxy liner. So now let's look at our traditional concrete or cementitious options. Okay, again, advantages and disadvantages. Advantages are, as you know, it's a very versatile, easily available, very economical material. It's strong structurally. It's relatively inexpensive, has a good lifespan if it's not corroded too badly by adverse conditions. But because of the adverse conditions found in manholes, they're usually top-coated with a barrier material like an epoxy or a urethane. The disadvantages are they're not always ideally suited for longevity in this corrosive kind of environment that we're talking about here. They do not handle the acidity well that comes from the sulfuric acid that we typically find in these conditions. So let's enter into the new generation. Now we're talking about the new generation of hybrid epoxies. Okay, what are these hybrid epoxies or epoxy-modified mortars that we're talking about here today? Let's get a little bit of a better understanding of exactly what it is this material is made of so we can better understand how to look at it. Okay, so hybrid epoxy essentially is an epoxy-modified mortar. Okay, so let's go back to a traditional concrete or mortar. If you imagine this is a matrix of a block of concrete or mortar, okay, we have sand and aggregate fillers that are in the matrix. These represent the circular, or represented by the circular particles here. And then we have the binder in between, the gray part. The binder on a typical concrete or mortar is usually a Portland cement. Okay, so it's a Portland cement mixed with water that creates a paste which becomes the binder. Okay, in the case of calcium aluminates, we have calcium aluminate cement, and pure fused calcium aluminate would represent pure fused calcium aluminate aggregates in between that are being held together by the binder. Okay, so that's traditional concrete or mortar. Now let's go to epoxy modified mortar. Okay, it's not always blue, of course, but here we go. So typically what we find is we're going to find very similar, if not the same, types of aggregates and fillers, because these are what ultimately creates the structural strength or the compressive strength of the product. However, in this case, the binder is a Portland cement and epoxy blend. We have a waterborne, typically, epoxy that is fused with the Portland cement to create the binder, which creates a totally different matrix for the epoxy modified mortar product than a traditional cement does. So, based on that, now let's look at poll question number 2. How familiar are you folks that are on the webinar today with calcium aluminate and particularly with pure fused calcium aluminate? Okay. 1, you don't know anything about it. B, somewhat familiar. C, you're very familiar. You have specified them as an engineer. D, you're very familiar, have used them as in a city or municipality or contractor. Or E, you know absolutely nothing about baked goods. Okay, so judging by the poll, it looks like there's almost a 50% of you folks that know very little about calcium aluminate. So if you'll humor me for a second, I'll just back up 1 second to the previous slide here and show you a little more information about, tell you a little more information about calcium aluminate. Let's go back to this original concrete slab here. If we look at the concrete slab, if this were calcium aluminate, okay, we would have traditional, this would be a traditional calcium aluminate. We would have very traditional, similar sand and aggregate fillers, just like with the concrete, but the binder itself, instead of being Portland cement based, would actually be a paste made from cement that is manufactured out of calcium aluminate. So it's calcium aluminate cement. It is a different process, similar process of manufacture, but it's a different raw material that is being used. The theory behind it is that the calcium aluminate is a more chemically resistant binder than the traditional Portland-based cement, and as a result should create a better product for this kind of application. Now, the difference between calcium aluminate, which I just mentioned and explained, and pure fused calcium aluminate has to do with the aggregates and fillers. The binder that we just discussed is going to stay the same. It's going to be the calcium aluminate cement-based binder. However, all the aggregates and fillers, in the case of pure fused, are also going to be calcium aluminate-based aggregates and fillers. And the idea behind the theory is that these aggregates and fillers, if they're also made of pure calcium aluminate, would also be more chemically resistant, and as a result, the entire matrix itself would have a much better chemical resistance than a traditional cement or than a traditional calcium aluminate. So I hope that helps. So let's fast forward now past the poll question where we were. Okay, so we'll ask ourselves, just how chemically resistant is pure fused, is epoxy modified mortar? Okay? In order to understand the next generation epoxy and modified cements, okay, how does the chemical resistance compare to calcium aluminate and pure fused calcium aluminate? So this is what this study was hoping to achieve here. So let's look at the source. So the source that we went to help us with this was Florida Atlantic University, based out of South Florida here. They have a very good science lab, and we approached them for help. And the purpose of the study was simple. They helped us come up with the scope for this, and the essential scope was, the purpose of the study was to compare the chemical resistance of calcium aluminate with next generation epoxy modified mortars in the acidic environment that you would typically find in a water and wastewater environment. We want to do a comparison of the two to see just how well does epoxy modified mortar hold up in this environment as compared to calcium aluminate and indeed pure fused calcium aluminate. So let's look at our study design. Okay, as we know, as I mentioned early on, sulfuric acid is a byproduct of H2S or hydrogen sulfide. So this is the acid that is found in the wastewater environment. And as a result, this is the acid that was selected to test the chemical resistance of these components in this study. 31% sulfuric acid was chosen in order to get accelerated results, in order to get a better result without having to wait multiple years to get a result out of the study. So a sample of each of the products was created, okay, a cured core sample, should we say, there'll be pictures in a second, of calcium aluminate, epoxy modified mortar, and pure fused calcium aluminate. Each sample was created to begin at approximately the same weight. Those weights were all within 1% of each other, so it was not a material difference in weight of the three core samples at the inception of the study. The cured samples would then be immersed fully in the sulfuric acid mix. The samples would then be removed, cleaned, dried, and weighed weekly for the process of 7 weeks, for the period of 7 weeks, in order to determine their respective weight loss and what the effect of the acidity was on each one of the cores. So let's look at some of the initial material samples here. The first one we have is the calcium aluminate. The core sample here you can see is still obviously intact. It's brand new. All of them were allowed to cure according to the data sheets beyond where they could be returned to service in a normal working environment. The calcium aluminate was about 987 grams. The epoxy modified mortar, as you can see by the blue color here, that's one of the differentiations, was 994 grams. And the 100% pure fused calcium aluminate was 981 grams. So they're all within 1% of each other's weights at the start. So after 3 weeks of exposure, and as I mentioned, we did do these weekly, but we started seeing material differences after 3 weeks, so we included the results of week 3 in the study, or so to say in this presentation. So the sample 1, the calcium aluminate, after 3 weeks, was down to 433 grams. Remember, we started at 987. Okay, that's about a 56% drop already in the weight. The epoxy modified mortar was just over 1,000 grams. And the pure fused calcium aluminate was down at 531 grams. So after 7 weeks, and this is where the study was concluded, this is what the final samples looked like. Calcium aluminate was down at 244 grams. The epoxy modified mortar was down at 992 grams. And the pure fused calcium aluminate was down to 361 grams. As you can see, the original weights are listed at the right below the actual current weights. So when we do a side-by-side comparison, let's look at what we actually found. Okay, the calcium aluminate lost approximately 75% of its weight after the 7-week immersion. The epoxy modified mortar lost 0.3% of its weight. and the pure fused calcium aluminate lost 63% of its weight. We look at those graphically now. We could see here the epoxy modified mortar is the orange line on the top, and the gray and blue represent the calcium aluminate and the pure fused calcium aluminate respectively. And you can see the dramatic difference in the weight loss after the immersion. All right, so that brings us up to question number 3. This is regarding understanding the pH levels of concrete. Those of you who are familiar with concrete will probably know what this is. So, what role, if any, does a pH reading play in the evaluation of concrete and concrete substrates? A, I feel it plays no role at all. B, it plays a small role, but I'm not sure exactly what that role is. C, it does determine the current strength of the concrete. D, it determines current and future strength. And E, it determines current and future strength, as well as the likelihood of embedded rebar corrosion. I'll give you a second to answer those questions. All right, great. So I'm looking at the poll, and it looks like the vast majority of people did pick E, which is good because that's exactly what we are finding. So let's look at the pH testing of the final samples. Okay, now let's discuss this a little bit regarding the pH. A pH, as I said earlier on, a pH level of 7 is considered neutral. The higher or more basic or alkaline the pH level is, the stronger the concrete remains, and the more likely it will potentially strengthen. As I mentioned earlier on, Portland-based cement concretes have been known to strengthen for decades after the pour, as long as their pH stays high. If the pH is neutral or lower, we start edging towards more acidic environment. It indicates that the samples will not continue to strengthen, and once it drops below neutral, we actually find that concrete will begin to start weakening, and as a result, start falling apart. Now, another interesting factor is that it has been determined that a pH level of 10 or lower, which would still be considered very basic and would still be considered pretty good for the sake of the concrete itself, would, however, still determine or result in the acceleration of the corrosion of any embedded rebar within the concrete. Okay, so if the pH is 10 or below, the rebar within the concrete still has the tendency to want to corrode. That corrosion will ultimately result in expansion of the rebar, which results in cracking and spalling. And that's what we find creates most of the damage in concrete. Rebar can expand to up to 7 times its original size once it starts corroding. And you can imagine what that does for a 0% elongation product like concrete that it's embedded in. So when we look at those samples that we had, we split each one of them down the middle, and in their centers we tested the pH. So the calcium aluminate had a pH of between 6 and 7. Again, this would be kind of just below neutral, so it's already beginning to weaken potentially. The epoxy modified mortar, the pH was between 12 and 13, which is really good, really high, which means not only is it very strong, but it's still protecting any rebar that might be embedded in there. And the pure fused calcium aluminate also was between 6 and 7. So what that's telling us is that ultimately, regardless of what happened on the outside, the absorption of the acidity into the core samples resulted in a diminishing of pH in the middle of the product too. So both of those products, namely the pure fused calcium aluminate and the calcium aluminate, absorbed acidity to an extent that even within the matrix, away from the contact areas, they lost strength and pH. The epoxy-modified mortar, however, kept its pH up very high, and in fact, you can tell if you look very carefully here in the central picture, if you look at the epoxy-modified mortar that has a high pH, the corrosion was actually nullified on the outside and almost created a barrier or a layer beyond which the acidity did not carry or transfer. So, our summary observations from this study showed the 100% pure fused calcium aluminate showed better performance than the traditional calcium aluminate. Both, however, showed significantly poorer performance than the epoxy-modified mortar. So if we look at the weight loss, first of all, again, after 7 weeks, let's recap. Calcium aluminate lost 75%. Pure fused lost 63% of its weight. The epoxy-modified mortar lost 0.3%. As far as the observed pH levels of the cores go, calcium aluminate was between 6 and 7, which is just below neutral. The 100% pure fused was also between 6 and 7. The epoxy-modified mortar, however, was in the 12 to 13 range, which is very highly basic, which is very, very good for the strengthening properties that you want to see in concrete. So, when it comes to applying products, let's look at application challenges. The poll question number 4 that we have for you is the following. What are the main concerns that you may have when applying manhole coatings and linings? And because we have a nice mix in the because we have a nice mix, I'm just telling now, I've just been told now, it looks like a poll question may not be up. Anyway, the question I had was, what are the main concerns when applying manhole coatings and linings? Does it have to do with cost? Does it have to do with cost? Does it have to do with complexity and the cost of the product itself? Does it have to do with pot life and working time? Or does it have to do with controlling the environment or the conditions, namely moisture, humidity, etc.? Or is it all of the above? So, again, when you're talking about application of coatings in manholes, are you concerned with the cost of the technical equipment, the cost of the product, pot life, controlling the environment, or is it all of the above? I'm not going to be able to see the poll results on this, but I'm guessing my gut instinct would be that most people will feel it's all of the above. All of those factors do play a role when it comes to understanding the complexities of applying a coating in a manhole. So, if we fast forward now, when it comes to epoxy-modified mortars, what we want to do is try and combine the best of both the epoxy and cementitious liners. Okay? When we look at cementitious liners, as we discussed before, we have the great things about cementitious liners are, as we said, they're economical, they're easily available, they're very easy to apply, very easy to understand, and very forgiving. But they're not so great with acidity, which we find in this environment. Epoxies are more costly, they're more complex, and they need often, depending on which polymer type you're applying, need a lot more controlled environment. However, they are more chemically resistant and as a result more long-term. So, if we put those best features together, we come up with a hybrid epoxy or epoxy-modified mortar. We have a product that's a lot more economical than a traditional epoxy would be. It's much easier to apply. It's chemically resistant, as we saw in the study, and it can be built as a high-build liner. So the great thing about this, again, is the application is as simple and easy as a cementitious liner. It can handle the moisture in the environment, can handle wetness in the surfaces. We all know those kind of conditions will never be eliminated out of the manhole structures, but at the same time, it doesn't come with the complexities that a traditional epoxy would. And it makes a really good solution that fits both of them. All right, so now we're going to take a minute to look at a couple of case studies. You've probably seen dozens of pictures like this in the past when it comes to manhole rehabilitation. The first one I'm looking at here is a project that was done in Brunswick, Georgia, by a company called Bionomic Services. They are a affiliate, or should I say a subsidiary of the Carillon Corporation, and they work together with a Cladliner distributor, Primeline Products, and I believe Primeline might be online today, so good job, guys. So if we look at the picture on the left, obviously we have a traditional brick manhole we can see here. You can barely see the bricks because the hydrogen sulfide has resulted in so much corrosion that we have all this corroded, powdery concrete and cement that's sitting on the surface. The manhole was power washed to remove all this. In some cases, we felt like it was not structurally sound, and being a brick manhole was very rough. So the contractor at that point determined that it made more sense to first resurface it with a high compression, 10,000 psi sewer grade resurfacing mortar. That resurfacing mortar is very similar to a mortar that we use, or was actually the product that was used, was Clad Restore. Was sprayed on using a wet spray method, or gunite spray. About an hour later, the Restore was firm to the touch, and at that point, the Cladliner, using the same spraying equipment, was able to be spray applied and back troweled over the resurfacing mortar. Now, we had one more picture after this which didn't make the slideshow, where they actually cleaned off the ring here. So I don't want you to think they do bad work. Typically, the ring would have been cleaned off, but what I wanted to just emphasize here was the application and the look of the product once it's done. This manhole was lined to maximize protection from hydrogen sulfide, and there was an I&I in this case. So the high-build epoxy liner would help mitigate both of those. So the second case study we have here, as you can see, these pictures were taken after it was a little more complete. This one took place in Bremerton, Washington. Bremerton, Washington is near the Seattle area. Those of you who have ever been out there, you'll probably know. The job was completed by a company called Provac, and Superior Supply was the distributor, the Cladliner distributor, that orchestrated the deal. The city of Bremerton, Washington had a manhole that was about 10 foot deep that needed to be repaired and restored for hydrogen sulfide and inflow and infiltration, I&I. In this case, because this was precast concrete and the manhole itself was in relatively decent shape, once all the leaks were stopped, the Cladliner was applied at a 1/4 inch, and as you can see, it was spray applied and then back troweled. As you can see by the finish, it gives you a nice, lustrous, shiny, colorful finish that ultimately will prevent the hydrogen sulfide from breaking down the concrete, as well as prevent any I&I from infiltrating into the structure later. At an application of a 1/4 inch thickness or more, I&I can be controlled with the epoxy modified mortar. Hydrogen sulfide, as we saw by the test, should be no concern when it comes to application of Cladliner in that kind of environment. So at that point, I've concluded with my case studies and my presentation. I'd love to take some Q&A if we have any at this point. Apologize again for that one poll that disappeared. I was going to town with it on my side, and apparently it didn't show up on the screen. So I think it was people were just trying to see if I would notice, and I guess I'd noticed, but a little too late. So with that, Vicky, can I turn it back over to you?
Yeah. Thank you, Dimitri. That was an informative presentation, and yes, we're sorry about the poll question not appearing. And it's now time for the Q&A. As a reminder, you can enter the questions in the panel in the left-hand portion of the screen. And if we get more questions than we can ask live, we'll address those off air. So the first question we have here, Dimitri, do hybrid epoxy systems work in wet and moist environments?
That's a great question. When doing manhole rehabilitation, any contractor or municipal folks that have actually been down in the structures know that in most cases, it's almost impossible to get those structures completely dry and to get them dry of humidity or lack of humidity. The Cladliner was specifically designed to be applied in humid but also moist and or wet environments that we find in those kind of structures. In fact, the wet surface is what we want to apply to. So typically what we recommend with contractors is as soon as the power washing phase is completed, that's when the Cladliner would be applied while the substrate is still moist.
All right. Now, the study, what did it reveal in terms of the matrix? Was the product weak after the study or still hard with high compression strength?
What we found with the epoxy modified mortar, as you could see in that one picture, the corrosion was very isolated to the surface of the product. So once that surface was breached by us, once we broke it in half, we found that beyond that very, very small surface area, the remainder of the block was not only compressively strong as it was when we started, but because of the high pH, indicating that it will still continue to strengthen over time.
Thank you. Does Cladliner contain antimicrobials?
Yes, it does. The Cladliner is the first product on the market that we are aware of that not only has an epoxy hybrid product itself in that it's very chemically resistant, but it has antimicrobial properties or antimicrobial added to it to give it that extra level of insurance to minimize any potential long-term chance of debilitation.
How does temperature affect the application of hybrid epoxies?
The way temperature affects it would be the same as it would probably affect any cementitious product, where you like to have ambient temperature between 75 and 85 degrees, and the substrate temperature, we would like the substrate temperature above 40 degrees. So in those kinds of conditions, the product would be able to be applied without any concerns. If the temperatures were outside of those ranges, as far as the lower range goes, those of you who have worked in those underground structures before know that the substrate very, very rarely goes below 50 degrees, even in the coldest areas, unless my friends in Alaska that experience the permafrost chime in here. But in most cases, the substrate is warm enough to accept the product. So the minimum temperature usually is not an issue, and the maximum temperature, if you have temperatures that are over 95 or 100 degrees, there are still ways of doing the application that would just have to be treated slightly differently with regard to making sure that we keep some of the moisture in the product during the curing process.
How easy is it to use a rebuilding mortar under Cladliner?
It's a simple process because Cladliner, at the end of the day, as we said before, marries epoxy with cement. So essentially, you almost have a primed cement that you're applying. So if you think about it this way, what we have is a very good bond between the two cementitious products. So as I mentioned in the case study before, the one in Brunswick, Georgia, if a high-quality approved resurfacing cement is wet applied to the surface, it does not have to cure fully before the epoxy modified mortar is added on the top of it. It can be added on top of it as soon as it is firm enough to accept the pressure of the trowel.
Other than resistance to acid, how does the mechanical properties, strength, adhesion, crack resistance of hybrid epoxy compare to standard mortar and epoxy?
It stands up really well. It's the PSI compressive strength is, I believe, just under 10,000, which is very high. As far as the crack resistance and adhesion goes, the epoxy itself gives it a much, much better adhesion than any traditional cement will give you, because the epoxy itself creates a very stickiness or adhesive property to the cement. As far as the cracking and so forth goes, in very, very hot, dry environments, it does still have the tendency to potentially crack the way a cement would, but not nearly as much. In traditional ambient conditions, it can be applied as thin as a 1/16 of an inch without cracking, whereas a traditional mortar, you normally have to go, a half inch or more to prevent any cracking from occurring.
Is there a chimney seal in the Cladliner line?
Yes, there is. A chimney seal was developed. It's called Clad seal. Those of you, we have a moment, go to cladliner.com would see it. It's a very interesting technology because one of the challenges we've always found with chimney seals is that they have isocyanates, so they're very dangerous to apply. They have low moisture tolerance, so they're very temperamental during application in wet environments, which is what we always found in manholes. And number 3, they traditionally do not have really good shelf lives. The Clad seal was specially developed to bridge all of those. It has a 2-year shelf life, it handles moisture in the environment, and it has no free isocyanates, making it very safe to apply, like 100% solids product in the field.
What conditions would a manhole have to be in where using the epoxy hybrid is not to be the best choice?
Well, the best choice, if the manhole itself was very badly degraded and you would need more structural capabilities, putting on 2 inches of the epoxy, the hybrid epoxy, while technically would work, would become economically infeasible. So at that point, we would recommend that a rebuild gets done first with a restore product like the Clad Restore before the hybrid epoxy is put over as a liner.
In these case studies, what was the thickness of the Cladliner product?
Sorry, what was that?
I said in these case studies, what was the thickness of the Cladliner product?
The specification for Cladliner typically is a 1/4 inch thickness. So it's a 1/4 inch applied to the substrate, assuming the substrate can handle that kind of thickness. So in the case of Brunswick, Georgia, we first did a restoration with the Clad Restore, whatever thickness that requirement was. I think that one was probably over an inch. And then we did a 1/4 inch of the Cladliner over the top of that. In Bremerton, Washington, the conditions allowed, so we just went directly with a 1/4 inch application of the Cladliner. In most cases, unless the conditions are very rough, a 1/4 inch will cover most rough edges, and as a result, a 1/4 inch of Cladliner is all that would be needed as a one-shot application.
How easy is it to apply Cladliner, and what kind of surface prep is required?
As far as surface prep goes, we always recommend we want to get back to a clean, sound, contaminant-free, pH-neutral substrate. In our case, with the Cladliner, we want it moist, so that's what we need for prep. Typically, power washing is all that's needed in a manhole. Depending on the conditions, it could be others, but usually it's power washing, so that would be the prep. As far as application goes, Cladliner can be applied in 2 ways. Number 1, for small applications where it makes sense, Cladliner can be applied directly out of the pail with a trowel onto the wall. Hand applied or hand transferred from the trowel onto the wall and trowel smooth. If larger structures or more volume is being achieved, as you saw in those pictures, a wet mortar spray pump can be used. The product would still be mixed up and then poured into the hopper or the auger, at which point it would be then transferred through the pump and sprayed to the wall. So the pump would then become the transfer mechanism to get the material to the wall, and then at that point it would probably be back-trialed to be smoothed down anyway.
What is the curing time for the product?
You'd start feeling firmness, depending on the conditions, obviously. If we're talking about 75 to 80 degree ambient conditions, you'd start feeling firmness probably within about 2 hours. Full cure is probably about 18 to 24 hours. However, because it continues to cure in moist, wet, and humid environments, unless the manhole itself is extremely aggressive when it comes to water flow, the structure can be returned to service once that initial firmness to the touch is reached, and it can continue to cure with the lid on and back in service.
Are the epoxies in Part A and B?
Yes, the Part A and the Part B has an epoxy in it, and those two are mixed up together. And to that you would add a Part C, which is a blend of aggregates and cement, custom made for this product.
At this time, are there any other manufacturers of hybrid epoxy systems?
In the manhole, when it comes to manhole applications, this is the only product we're aware of in the market that takes advantage of this technology as we see it today.
Does Cladliner train and certify installers, or can any contractor apply the product?
Any contractor can buy and apply the product. However, depending on the markets that the contractor is in and the distributor they're dealing with, that distributor may or may not have a specific training program available to them. So any person can buy the product, but if they do want to carry warranties and so forth, or if they do want the training, that would be something they would deal with a local distributor on. For example, I know that here in our Florida market, Primeline is very good about having a comprehensive training and support program to support the contractors so that they know exactly how to use the product before it is being applied.
Can you apply Cladliner at the bottom of a manhole when it's wet?
Cladliner can be applied on the bottom when it's wet. The only concern would be if we have water running through the channel, we can stay out of the channel. If we need to line the channel, the flow, if there is any flow, would have to be stopped before that area got lined, and the product would have to reach some form of cure before the channel was released to have service again. Because if the channel gets released and the water runs over the Cladliner, it will still continue to cure. However, if the water is aggressive enough that it washes away the product while it's soft, that is a problem that we need to deal with.
Is this more economical than a traditional epoxy or cement?
It kind of falls somewhere in between the two. It's much more economical than traditional epoxies you'll find, and much less complex, and a little more expensive than a traditional cement, but right there in the range kind of where the pure fused calcium aluminates in the market would be.
Does the product shrink during or after the curing process?
There is very little shrinkage in the product because even though it has a waterborne epoxy, the water that comes off the curing of the epoxy actually gets sucked up by the cement, so there's very little shrinkage.
Is there any type of testing that is done to ensure the minimum thickness of liner is applied and it has full coverage, like the spark test?
Yes, so spark tests are not going to be easily done with this product because they have moisture in them. So spark tests work with 100% solids epoxies because there's no moisture in the epoxy, and it's looking for the moisture in the concrete behind it. Because the cementitious, or should I say the hybrid epoxy, is so similar to the cement in some of its properties, the spark tester would read the epoxy liner or the hybrid epoxy liner as part of the concrete substrate behind it. However, because the product itself, as you can see by the color, is a rich blue color, and it's typically being applied at a 1/4 inch, the thickness can be measured using a wet film gauge during application. It is quite easy, because of the color difference, to see whether we have any holidays or discontinuous areas when the application is complete.
Can EMM be used for new manhole construction?
Yes, they can. Epoxy modified mortars work really well for new manhole construction. If they're in areas where we are not so concerned with too much I&I initially, because these are all brand new structures, an 1/8 of an inch of the product might be perfect for those kinds of environments. If we're anticipating a lot of I&I in the future, then a 1/4 inch would probably still be recommended. But this is a great product for applying on new structures.
Can this product be used on other structures, like clarifiers or digesters?
Yes, it can. It can be used on those environments. However, depending on the aggression of the environment, I would say to check with your local distributor to see if it makes sense in those particular cases. There are some environments that even traditional epoxies that are not specialized, would still not hold up. So if you had a situation where the environment was very, very aggressive, I would check with your local distributor before determining whether that would be a good fit or not.
What is the pot life for these products?
The pot life for the Cladliner is approximately 60 minutes. So you have about 60 minutes to work with the product during application.
And what part of the country is this product used mostly in?
Right now, it's being used in numerous places around the country. We have a distributor based out of Florida. There's a distributor based out of Minnesota. They're called Floor Coat. And we have a distributor, as I mentioned earlier, on Superior Supply in the Pacific Northwest. However, we have done the product has been used as far south as Southern California, Texas, and Arizona, and it's starting to be used in many more markets as we speak.
All right. Well, thanks, Dimitri. We had many great questions today that we did not get to address during this live Q&A. These will be addressed offline via email. As a reminder, that the 4th poll that was not loading has been added to the post-event survey, and the results will be displayed upon answering. This concludes today's session of the Trenchless Technology webinar series. Thank you to all of our attendees for joining us today. I would also like to thank Dimitri for his participation and Cladliner for sponsoring the session. As a reminder, today's webinar will be archived at trenchlesstechnology.com under the Education tab, if there is something you missed or would like to refer back to. Thank you again, and we look forward to seeing you online at a future webinar.